linked list. So we are not going to talk about linked list versus arrays versus linked list, and so on, perhaps some other day. Basic fundamentals of linked list is that you have a node, and that node points to some other node, that node again points to some other node, and so on and so on and so on. So a chain of nodes is created, and so they're all linked. Okay, so that's hence the name linked list. Okay, so all the linked lists have some sort of like start position and an end. So the start, some of the terminology is that when somebody says head, it points to the first node, which is the starting of the node in the chain, and you can keep iterate using that the head. You iterate over the nodes, and you can basically append data to a node, add a new chain, add elements into the node, and so on and so on. Okay, so the basic structure of a linked list is a node. So let's create a node first. Okay, node in Python would be a class, and I'm going to define an initializer which takes up a value. A lot of people think that this is a constructor, but this is not. This is basically initializer. Okay, so self.value, that's equals to value. Oh, and I need to create next. So this is important part of a node. A node next points to the another node, and so on and so on. So this is what creates the chain, the link. Okay, so next, and that's equals to none. By default, it doesn't point to anything. Okay, so now let's implement a linked list. So what we have defined is just a node which holds two types of values. Basically, it holds a value and it holds next. So value is your any kind of value, a number, strings, or whatever, and your next points to a new node, and again, and so on. So basically, this is how we create a link node, one node to the other node, and so on and so on and so on. Okay, so let's implement a linked list class, which is going to help us implement this chain of nodes. Okay, so linked list again. Let me define constructor. Oops, an initializer. Sorry. Self.head. So this I'm defined self.head, which means that every node, every linked list has a self.head which points to the first element in the linked list, and using this first element in the linked list, we can iterate over the linked list and do some operations, right? So now this is fine. Now I need to create a method to actually insert a value into the linked list, right? So let me call this function as append, just like Python list has an append function similar to that. So the same thing. So we're going to append and takes up a value. Now this is where you have to be a little bit careful. The first thing is that let's say you want to append a value to the linked list and does not contain any nodes. It does not contain any nodes. It doesn't have any nodes. Well, what are you going to do? So we have to create. First, let's create a node. Now, this is a constructor, not an initializer. This is an initializer. This is the constructor. Okay. Yeah. So now, what if self.head is is not, sorry about the typos. I'm having a lot of typo today. Self.head is not none. So that means there are existing node in the linked list. So, but if self.head is none, so it doesn't contain any node. So we can just do self.head to point to new node that we created. Okay, so this is important now. Okay, so what we do is that now this is very important in any linked list. We don't want to lose the self.head. So there's a lot of this initially. You have to get some practice on how to make sure that you don't lose reference. It's very easy to break the link. So what we do is first we create an invariant variable, and that points to self.head. Okay, now while my current dot next, that means current is pointing to a self.head. Self.head is nothing but it points to a node, and that node contains next and value. So while current.next points to a node, okay, so we are going to traverse through the node, and is equals to next. Okay, so what we're doing here is basically we start from the head using a current which points to self.head, and we iterate over from one node to the other node. So how do you jump from one node to the other node? Using current.next. My current.next will be pointing to the next node. So current is equals to current.next. That means I am jumping to the new node, and so on and so on and so on till I reach a node where current.next is none. It doesn't, I have to reach, right? I have to reach to a node that is a tail node. Tail, just like head is basically points start of the node, tail is the end of the node. So here I'm going to the tail of the node, I come out of the loop, now my current is basically pointing to the tail of the node. So, and what I do is very simple. I will just do current points to current.next. Oops. Current.next now points to the node, the newly created node. Yeah, so this is how it works. Now, this is the fundamentals of implementation of append. So when I call an append function and to the linked list, I'll pass a value. I'll first check whether the head points to none. That means what I'm doing is I'm asking linked list that, hey, do you got a node, existing node? And it says, no, I don't have a node. Then it's very simple. I just create a node. I point that self.head to node. That's it. It's the first item in the node. Very easy peasy. But if there's a node, existing node, then things change. So I need to traverse through the chain, through the linked list, and to find the tail node. How do I get to tail node? How do I know it's a tail node? In linked list, the tail node is a node which doesn't point to anything. It next points to none. Okay, so I iterate, get that tail node, and then current.next points to that node, the newly created node. That's how you append at the end of the tail. So that again, so the tail is the new node. Sorry, the new node is the tail. The node that append is the new tail. Oops, sorry. I hope I'm not confusing you guys. Okay, so let's implement a way to actually print the values that I've inserted into the linked list. So I'm going to implement a similar logic, just like a list works in Python. So I'm going to define iteration protocol. So I'm not going to talk about this how it's going to work in iteration protocol. I'm not going to talk about this. So that's some other day. But iteration, when you implement something like a for loop, it internally calls this iteration protocol. And iteration protocol is basically iteration protocol, and then it returns a value, and that is the value you get when you run for loop in a list or for loop. So all these strings, lists, tuples, and dictionaries, they all implement something called as iteration protocol. So they return a value when you run over a for loop. This is where the concepts of next, iteration protocol, yields, and generators goes and come, and all those things are there, which you need, we're going to talk about perhaps in the future. Okay, so iteration protocol again. Again, we're going to do some checking here. If my self.head is not none. Oops. Okay. Then I need to iterate and print the values. Else, what I have to do is simple. I'm just gonna return stop iteration protocol. Yeah. So this is a stop iteration exception. So when I'm implementing in a for loop, when for loop gets the stop iteration method, what it happens is that it will stop the for loop. It's done. It's done its job. So this is how it works. Okay. So there's nothing to iterate on. So this is stop iteration. So this is how you make iteration protocol stop. Okay, so now let's implement this. Again, the same, I'm going to implement a current, which points to the self head, which points to the head, the start of the node. And now I'm going to just do a while loop. While current is not none. I can actually do while current, that is fine, but I'm just kind of doing this while current is not none. I'm checking this for people who are coming from, languages such as C++ and all, where you have to check for, hey, if the value is equal to null or not equal to null. So Python takes care of that. It's dynamic typed, so whether current is a bool type or none type, it will stop the iteration. Okay, so while current is not none, now what we're going to do is simple. We are just going to yield. Now again, we're not going to talk about yield versus this yield and generators and all those things, so that's on some other day. Yield is basically we're yielding the value, current dot value. Okay, so yield current dot value while current is not none, yield current dot value, and update the current to jump to the next node, current dot next. Okay, so that's it. So this is going to iterate, and it's going to yield the value current dot value. So again, we are not going to discuss about yield, how it works. You can actually implement print here instead of yield. You can just say print current dot value. That's also fine. So let's test this. Let's test our logic if it's correct or not. What's the point if we're not going to test, right? Okay, yep. Now again, we're not going to talk about name equal to main. This is basically the module name. Okay, so linked list. Let me create a linked list class. Linked list.append 10. Okay, let me append some few values for testing purposes. That should work. Okay. Now I'm gonna implement a for loop. This for loop is gonna actually call the iteration protocol, the iter method that I have defined, dunder iter method. So all your for loop, all your lists, strings, they all implement this iter method internally. So that's a reason why you're able to do iterate over them. So for item in linked list. So print. Okay, let's see. Boom, it worked. Cool. So 10, 20, and 30, that's fine. So our linked list implementation is working. Let's test a few more stuff. Okay, let's implement, let's say if I have only one element. Ooh, that's awesome. What if I don't have anything? Boom. So this is it, right? So what just happened here is that I don't have any elements. So this goes to this part of the line. It executes return stop iteration, and the for loop knows when it reaches stop iteration, and it just doesn't iterate. Done. Okay, so now let's implement delete. Now this is a little bit okay, sorry, we're going to implement actually reverse. So reversing the linked list. How am I going to do this? Okay, reversing a linked list is a little bit more complicated than appending. Appending is basically you iterate, go to the tail node, boom, you append the node, the new node that you have created. But reversing a linked list requires a little bit more work. Okay, so let's do this. Define reverse. Okay, reverse, and okay, the first thing you want to do is that again the same check if self.head, self.head is not none. We're going to implement that logic later. Else, I don't know why I'm having so many typos today. Okay, else we're going to just return self.head. We're not going to do anything here. Okay, so the way reverse works is basically we use the same logic as when we are iterating over the linked list. We start with current, which starts from self.head, and as we jump from one node to the other node and other node and so on. The same thing happens in reverse. We start with the self dot, we start with the head node, but how we reverse is basically we take that current node and point it next to the previous node, and again we jump, and then again we point the current node to current nodes next to the previous node, and so on and so on. So what actually happens, and then once the iteration is done, we point the tail node, because we have exited the loop, we point the tail node and we update the head becomes the tail becomes the new head. Okay, so okay, that's a lot of stuff to take on. Okay, so I'm going to implement this, so let's that'll be much more clear for you guys. Okay, self.head is not none. That means there are node which is existing. There are existing node in the linked list. So first, let me define current, which is going to point to self.head. Now there's something which is I'm going to define another variable. This is an important one, because now I need, whenever I do this, when I said that current's next points to the previous, basically I'm losing that next, right? I'm breaking the chain. So we don't want to do that. We have to be careful with that. We don't want the next to we don't want to lose the next. So we have to somehow way to protect it. We want to save it in some variable. So to do that, we maintain two pointers. One is next and the other one is previous. The previous by default doesn't point to anything. We're starting from the head. It points to empty none, right? It doesn't point to anything. So previous will previous points to none. Oops, none. And while my current okay, so previous, let me be more clear. Previous node is none. While current exists, I am going to first store this, my next, into a variable called next node, so that I don't lose my current node, and it's easy for me to actually update the current. So let's see how we're going to do that. So next node is going to become equal to current dot next. So I'm pointing the current dot next to I'm storing the reference current current dot next to the next node. Okay, and then I am current, as I said, current dot next now points to the previous node. This is very important. This is the important logic, because now my current node next points to my previous. Okay, and my next node, but at the same time I also saved the next reference. I have not lost it. Okay, now then my current will become equal to next node. Yep. So, but there is a problem here. What about my previous node? Yep, that's a problem. So my previous node will become equal to, now current is pointing to the next. We lost the current, right? So we don't want to do that. So my current is going, my previous node needs to point to the current. Yeah, that's much more. That's correct now. So let's see what we're doing here. Now, okay, so I'm starting with current. I'm protecting self.head. I don't want to lose self.head. If I lose self.head, I'm losing all my linked lists. I don't want to do that. Now I'm creating another variable called previous node. So I make use of two variables, next node and previous node. The next node points to the current node's next, and previous node points to current node's previous value. So by default, previous value will be pointing to node, none, a node which is empty, none. It's not pointing to anything, just none. Now I iterate, every time I iterate over the node from one node to the other node, I'm updating the current node, but at the same time I'm changing the current node's next to its previous node. This is where, but at the same time, when I do that, I also need to store the next reference. Otherwise, I'm going to lose it. So that's the reason I have to do this. Next node points to current.next. Yeah, done. So when I come out of the loop, come out of this while loop, now my current is none. So you might be saying, I can just make self.head is equals to current. No, self.head is wrong. Current is actually pointing to none. So that's the last tail element, right? The tail. As we said, the tail always points to the none. Tails, a linked list node, tail node, next always points to none. That's how we know that that's the tail. Okay, so what do we do? But the previous node is pointing to the previous node. That's the tail node. So what we're gonna do now is self.head will become equal to the previous node. Okay, let's see what just happened. When I come out of the loop, my previous node is actually pointing to the tail node. My current is actually pointing to none. It's not pointing to anything, because next.node will, as I iterate, next.node will become equal to current.next. Current.next is going to be none, and current and then current is going to update to next node. So this is how reversing will work. So we make use of two important variables, that is previous node and the next node. So we have to be very careful we don't lose the references. So basically, as we iterate from one node to the other node and so on and so on, we make sure that that node next points to the previous node, and we jump to the next node, and that next node next will point to the previous node, and so on. Okay, I hope I was not confusing you guys. So yeah, let's actually test this. Let's test. Okay, print. Okay, so linked list dot reverse. Okay, I'm gonna just run through the for loop that we implemented. Okay, that should work. Boom, yeah, it worked. So 10, 20, 30, and 40. That's how we inserted. We printed the values and then called the reverse, which reversed the linked list. Let's do some more logic. Let's say if there's only one value. Yep, that's again valid. Okay, let's see if I have only two values. Still it's working. That's okay. So we have successfully implemented linked list reverse. Cool. See you guys in the next video. I hope this helps. This was my first video in YouTube. Yeah, a lot of rough edges. See you guys later.